Question 1. To illustrate this point, imagine Bennett, an HVACR training manager, is tasked with developing a new training program for entry-level technicians in a company rapidly transitioning to dope refrigerants, while her initial instinct is to reuse older modules from a previous ARC-22 program. She is cautioned by peers to consider a more strategic approach aligned with current regulatory and market shifts. What is the most effective step Bennett should take to ensure relevance and long-term impact of the training curriculum? A. Reformat older training slides to include mention of new refrigerants only in the appendix. B. Conduct a job task analysis to identify competencies needed for modern refrigerant systems. C. Use the EPA Section 608 syllabus as the only content basis. D. Focus exclusively on hands-on recovery machine training for now. Answer. Correct answer. B. Explanation. A job task analysis (JA) ensures training aligns with industry needs, evolving technologies, and safety regulations. ANSI STMI 65918. Merely updating old materials. A. Risks irrelevance. Relying only on Section 608. C. Omits broader practical competencies. Focusing only on equipment. D. Ignores foundational knowledge. A DA ensures learning outcomes map real-world tasks in the context of a DDoP refrigerants and regulatory compliance. RE guideline for technician training. Question 2. In a modern context of refrigerant transitions, which of the following statements best explains the implications of using our refrigerants in systems previously designed for our refrigerants? A. Our refrigerants require higher operating pressures, thus needing compressor retrofits. B. Our refrigerants are non-toxic and non-flammable, so no changes are needed. C. Our refrigerants are mildly flammable and require ventilation and leak detection protocols. D. Our refrigerants reduce oil return effectiveness, so systems must run cooler. Answer. Correct answer. C. Explanation. Our refrigerants like R32 and R454 are classified as mildly flammable under ASHRAE Standard 34. This requires compliance with IL 60335-240, including additional ventilation, leak detection, and proper airflow management. Option A is incorrect. Not all ALs require higher pressure. Option B misclassifies flammability. Option D is misleading. The oil return issues are more related to velocity and piping design and refrigerant class. Flammability risk and proper safety controls are key training points per ISO 817 and ASHRAE Guideline 15. Question 3. Among the various electrical issues encountered in HVAC systems, a technician consistently observes nuisance tripping of a compressor contactor. After replacing the contactor twice, the issue persists. Which of the following is the most likely root cause? A. The compressor motor winding has low resistance causing overcurrent draw. B. The thermostat anticipator setting is too low. C. The contactor coil voltage rating exceeds the control circuit voltage. D. The contactor is rated or DC while the system uses AC. Answer. Correct answer. A. Explanation. A compressor winding with low resistance will draw excessive current, causing contactor tripping per NEC Article 430 in Ohm's law. Options B and C may affect control performance but not contactor tripping under load. D would prevent coil operation, not cause tripping. Proper use of multimeters to test winding resistance and amperage against nameplate ratings is essential troubleshooting under NFPA 7 TIP and IC 60364 guidelines. Question 4. With the advent of energy recovery ventilators, ERVs Chavez installs a system in a commercial office to improve indoor air quality. After commissioning, CO levels remain high despite adequate outdoor airflow rates. What is the most likely cause? A. The ERV core is undersized for peak occupancy ventilation. B. The system lacks CO sensor at the return duct. C. The ERV is in economizer mode continuously. D. The return grill is located too close to the supply diffuser. Answer. Correct answer. A. Explanation. An undersized earth core may limit heat and moisture exchange, compromising ventilation efficiency and failing to dilute CO. ASHRAE 62.1 2022 recommends demand-controlled ventilation, D/V, and appropriate ventilation effectiveness based on occupancy. Option B may aid in control but doesn't fix exchange capacity. C is irrelevant if CO is high. D could cause short cycling but not sustained elevated CO. Earth sizing and placement per manufacturer and ASHRAE guidelines is critical. Question 5. In light of recent developments, a training manager, Mr. Rowan, is creating a refrigerant handling workshop. He wants to demonstrate safe evacuation practices for HFC and HFO refrigerants. What best practice must he include during the practical training segment? A. Opening system valves to the atmosphere after pump down. B. Using a vacuum pump with a micron gauge to achieve 500 microns. C. Recovering refrigerant into a recovery tank only when it's above ambient pressure. D. Venting residual refrigerant during brazing if the system was recently serviced. Answer. Correct answer. B. Explanation. Per EPIS section 608 NRE guideline K, a deep vacuum 500 microns ensures removal of moisture and non-condensables before recharging. Options A and D violate Clean Air Act 40 CFR Part 82. Option C is unsafe. Recovery should be complete regardless of pressure. Micron gauge use, filter dryers, and compliance with industry vacuum standards are essential elements of technician training in safe refrigerant management. Question 6. From the perspective of system design, which of the following most directly leads to occupant discomfort and excess energy use in a ducted split system? A. Oversizing the evaporator coil to match peak latent load. B. Using rigid ductwork rather than flexible ductwork. C. Poor insulation of return ducts in unconditioned spaces. D. Designing supply registers to throw air directly at occupants. Answer. Correct answer. C. Explanation. Uninsulated return ducts in attics or crawl spaces allow heat gain, impacting load calculation accuracy and return air temperature. This reduces system efficiency and comfort as per a CAM manual. D and ASHRAE fundamentals. A. Can help latent load control, not discomfort. B. Rigid ducts often improve airflow. D. May be a comfort concern, but less impactful system-wide. Proper duct insulation is required by codes like ICAN improves energy efficiency. Question 7. Given the circumstances, Mr. Chen is mentoring a new technician, Sarah, who consistently bypasses safety lockout circuits during troubleshooting. Mr. Chen has warned her verbally twice, but behavior persists. What is the most effective next step? A. Suspend Sarah from field work and terminate her mentorship. B. Report the behavior directly to HR and disengage. C. Create a written corrective action plan and reinforce consequences. D. Pair Sarah with another mentor to diffuse conflict. Answer. Correct answer. C. Explanation. Creating a written corrective action aligns with HR practices and mentorship ethics, REFERT-RM and EPISAFE work practices. It documents accountability while giving Sarah a chance to improve. Immediate termination, A, or deflection. D. Doesn't correct the safety violation, reporting to HR without follow-through. B. May avoid responsibility. Mentors must model safety and address unsafe behavior clearly and formally. Question 8. Examining the consequences of low subcooling readings on a system operating in cooling mode. A senior technician suspects a problem. Which of the following most likely explains the low subcooling condition? A. Undersized condenser coil limiting refrigerant condensation. B. Non-condensable gases accumulating in the condenser. C. Restriction in the liquid line after the metering device. D. Low refrigerant charge resulting in incomplete condenser fill. Answer. Correct answer. D. Explanation. Low subcooling indicates insufficient refrigerant in the condenser coil. Per NATE and RE diagnostics, this typically results from undercharging. A. May reduce efficiency but not necessarily subcooling. B. Would raise both head pressure and subcooling. C. Is incorrect. Liquid line restrictions reduce flow but do not directly lower subcooling. Superheat and subcooling together reveal charge-related issues. The proper gauge use is essential. Question 9. Through careful analysis of adult learning theory, what instructional method is most effective in HVACR technical training for maximizing skill retention? A. Lecture-based delivery with end-of-course exams. B. Self-paced modules with optional practical tasks. C. Scenario-based learning with hands-on simulation. D. Memorization drills and weekly quizzes. Answer. Correct answer, C. Explanation. Adult learners benefit from relevance, application, and engagement. Per Malcolm Knowles' andragogy principles, scenario-based learning with simulation boosts retention and mirrors real job tasks. Lecture only 8 lacks interactivity. B. Risks disengagement without accountability. D. Emphasizes rote memorization over conceptual understanding. Effective HVAC training integrates hands-on tasks, collaboration, and immediate feedback. Question 10. The effectiveness of modern building management system (BMS) depends on integration and fault tolerance. What is a key reason why backend METP networks may become unstable in large installations? A. Using shielded twisted pair cable instead of unshielded. B. Having too many end-of-line terminations. C. Installing devices without assigning unique MAC addresses. D. Using Modbus compatible controllers in backnet loops. Answer. Correct answer, C. Explanation. Backnet METP networks require unique MAC addresses for each node to avoid collisions and communication errors. ASHRAE 135 standard. Duplicated addresses cause network instability. A is generally good practice. B. Too many terminators may degrade signal but not always cause failure. D. Protocol mismatch prevents communication entirely, not intermittent instability. Proper addressing and segment planning are key in BMS commissioning. Question 11. Considering the evidence ISTA Singh is supervising the installation of AES system in a commercial building, the outdoor units are installed in a confined space with minimal ventilation. Which of the following installation practices is critical to ensure proper operation and compliance? A. Installing additional exhaust fans to maintain ambient temperature below manufacturer limits. B. Sealing the outdoor unit enclosure completely to prevent dust ingress. C. Using standard HVAC condensate drains without slope for ease of installation. D. Placing refrigerant piping underground to protect it from UV exposure. Answer. Correct answer. A. Explanation. ERF outdoor units require adequate ventilation to dissipate heat, preventing compressor overheating and ensuring performance per manufacturer guidelines and ASHRAE standards. Sealing the enclosure. B. Traps heat and reduces airflow, causing system failures. Proper condensate drainage. C. Requires correct slope per ANSI to avoid water damage. Underground piping. D. Is sometimes used but must comply with local codes and be well insulated. Ventilation is paramount for ERF outdoor equipment. Question 12. Under the assumption that a trainee technician discovers a critical safety violation during an HVACR system inspection, but the client insists on postponing repairs for budget reasons, what is the best ethical action for the technician to take? A. Document the violation in the report and proceed with the work as planned. B. Immediately shut down the system regardless of client wishes. C. Clearly communicate the risks, recommend repair, and escalate to management if ignored. D. Ignore the violation to maintain client satisfaction and avoid conflict. Answer. Correct answer, C. Explanation. Ethical practice as guided by the HVACR Code of Ethics and OSHA regulations requires technicians to inform clients of safety risks clearly and recommend corrective action. Documentation protects the company and customer. Immediate shutdown. B. May not be feasible or legally required unless imminent danger exists. Ignoring issues. D. Breaches professional responsibility. Escalation ensures compliance and safe operation. Question 13. From the perspective of preventive maintenance, IS Lopez notices repeated compressor failures on a rooftop unit. The maintenance checklist includes filter replacement, refrigerant charge check, and coil cleaning. What additional maintenance action is most critical to prevent compressor burnout? A. Regular oil analysis and replacement schedule adherence. B. Increasing condenser fan speed for better cooling. C. Lowering the system operating pressure set point. D. Frequent refrigerant purging to remove non-condensables. Answer. Correct answer, A. Explanation. Compressor lubrication is vital. A degraded oil leads to wear and overheating per OEM guidelines and ASHRAE maintenance standards. Oil analysis detects contaminants and breakdown. Increasing fan speed. B. May help heat rejection but does not address mechanical lubrication. Lowering pressures. C. Risk system imbalance. Refrigerant purging. D. Is important but less frequent than oil maintenance. A robust oil program extends compressor life significantly. Question 14. While examining a split system, a technician notes superheat is excessively high but subcooling appears normal. What does this combination most likely indicate? A. Overcharged refrigerant system causing liquid floodback. B. Restricted airflow over the evaporator coil. C. Undersized metering device or blockage in the evaporator. D. Low refrigerant charge or restriction in the liquid line before the metering device. Answer. Correct answer. D. Explanation. High superheat with normal subcooling usually indicates low refrigerant reaching the evaporator caused by undercharge or liquid line restriction before the metering device, reducing evaporator coil saturation per account manual RS diagnostics. Overcharging A would cause low superheat. Restricted airflow B increases both superheat and subcooling abnormalities. An undersized metering device C causes low superheat due to flooding, opposite of the observed. Question 15. When evaluating the merits of various HVAC systems for a new commercial building, Mr. Young is comparing SEER ratings among models. However, he notices that two units with identical SEER values differ significantly in annual energy cost. Which of the following best explains this discrepancy? A. One unit uses a variable speed compressor while the other uses a fixed speed compressor. B. The units have different nominal cooling capacities but similar SEER ratings. C. The units are rated at different indoor evaporator temperatures. D. One unit's ER rating at peak load is significantly lower despite similar SEER. Answer. Correct answer. A. Explanation. SEER reflects seasonal efficiency but doesn't capture part load performance nuances. Variable speed compressors modulate output and reduce cycling losses, improving actual energy cost savings beyond SEER ratings. Fixed speed compressors run at full load and cycle on-off, increasing energy use. Nominal capacity differences. B. Impact sizing, not SEER alone. Indoor temperatures. C. Effect rating conditions but are standardized. D. Reflects peak efficiency, less impactful on annual costs. Question 16. Given the circumstances, a training manager is tasked with reducing departmental expenses by 20% while maintaining training quality. Which strategy balances cost saving and effectiveness? A. Reducing instructor to student ratio to increase group size. B. Cutting equipment purchases and increasing reliance on simulation software. C. Eliminating safety and regulatory content to save time and cost. D. Outsourcing all technical training to online vendors. Answer. Correct answer. B. Explanation. Simulation software provides scalable, cost-effective hands-on experience and complements physical labs, aligning with OSHA and EPA best practices for safety and regulatory training. Increasing group size. A. Risks reduced individual attention, potentially hurting quality. Eliminating safety content. C. Violates compliance and risks liability. Fully outsourcing. D. May reduce quality and essential in HVAC skill mastery. Balanced resource use is critical. Question 17. During the process of training a technician on refrigerant recovery, the instructor observes the trainee using an improper gauge manifold that is not rated for the refrigerant type. What is the most important reason this practice must be corrected immediately? A. The gauge manifold may give inaccurate pressure readings. B. The manifold may corrode quickly due to incompatible refrigerant. C. The manifold's materials might react and cause hazardous leaks or explosions. D. The gauge manifold may be heavier, causing handling difficulties. Answer. Correct answer. C. Explanation. Using tools not rated for specific refrigerants, especially mildly flammable or new refrigerants, can lead to material incompatibility, causing leaks or ignition hazards as per EPA and OSHA guidelines. Accuracy A is important but secondary to safety. Corrosion B affects durability but less critical immediately. Weight D is not a safety concern. Correct equipment ensures compliance with all and CSA standards and protects personnel. Question 18. while examining the training records of several apprentices is to grant notices that one has consistently underperformed in electrical troubleshooting despite repeated coaching. What is the best approach to help this trainee improve? A. Assign more advanced tasks to build confidence. B. Refer the trainee to remedial instruction focused on electrical fundamentals. C. Remove the trainee from electrical tasks and assign purely mechanical work. D. Continue current coaching approach and hope for gradual improvement. Answer. Correct answer. B. Explanation. Targeted remediation addresses knowledge gaps per adult education principles, NULs. Assigning advanced tasks. A. Risks failure and demotivation. Removing responsibility. C. Limits career growth. Passive coaching. D. May not address root cause. Remedial training ensures foundational understanding necessary for complex troubleshooting, aligning with effective mentorship best practices. ASTME. Question 19. As demonstrated by the recent push for greener HVAC solutions, a training manager wants to implement continuous improvement in his department. Which approach most effectively embeds continuous learning into daily operations? A. Holding annual refresher courses and updating manuals. B. Establishing a feedback loop with technicians to capture field experiences and adjust curriculum quarterly. C. Mandating monthly written tests on new technologies. D. Relying on manufacturer seminars to deliver new content. Answer. Correct answer. B. Explanation. Continuous improvement is dynamic and relies on real-time feedback and iterative updates. Engaging technicians leverages practical insights, improving curriculum relevance. ISO 9001 principle. Annual courses and monthly tests. C. Are periodic, not continuous. Manufacturer seminars. D. Supplement but don't replace tailored departmental adaptation. Active, participative processes enhance training effectiveness. Question 20. When analyzing a hydronic heating system with multiple zone valves, a technician finds uneven heating across zones despite balanced flow settings. Which of the following is the most likely cause? A. Improperly sized circulator pump leading to inadequate flow rate. B. Using manual balancing valves instead of automatic ones. C. Zone valves wired in parallel causing simultaneous opening. D. Air trapped in the system causing hydraulic imbalances. Answer. Correct answer. D. Explanation. Air pockets disrupt flow, causing noise and uneven heating. Proper purging and air elimination per ASHRAE and hydronic standards are essential, while pump sizing affects overall flow. Imbalance is more likely from trapped air. Manual valves B. Require regular adjustment but are not direct causes of uneven heat alone. Parallel wiring C. Might affect control but does not cause hydraulic imbalance. Effective air management is critical for system performance. Question 21. In comparison with traditional diagnostic approaches, Mr. Allen is training his team to use smart meters and air sensors for real-time HVAC system monitoring. During a system fault, the sensors report fluctuating suction pressure but stable head pressure. What should the technician suspect based on this data pattern? A. A clogged orifice or E6B malfunction causing erratic refrigerant flow. B. Compressor mechanical failure causing pressure instability. C. Condenser fan motor intermittently shutting off. D. Low refrigerant charge leading to unstable suction pressure. Answer. Correct answer. A. Explanation. Fluctuating suction pressure with stable head pressure often indicates irregular refrigerant metering device operations such as a clogged orifice or malfunctioning thermostatic expansion valve (TSV). Compressor failure B. Typically affects both pressures. Condenser fan issues C. Affect head pressure more. Low charge D. Usually causes both pressures to drop. Interpreting sensor data requires understanding refrigerant flow dynamics and component functions. Manual ORS. Question 22. Throughout the course of a system overhaul, the technician replaces an original reciprocating compressor with a scroll compressor on a residential heat pump. Which consideration is critical to ensure proper operation after replacement? A. Verifying oil compatibility and capacity for the scroll compressor. B. Using the same crankcase heater voltage rating as the original. C. Maintaining the exact same compressor model number for warranty compliance. D. Ensuring the discharge line size matches the original compressor specs. Answer. Correct answer. A. Explanation. Scroll compressors often require specific oil types and charge volumes different from reciprocating types at ASHRAE handbook. Oil incompatibility or incorrect quantity risks premature failure. Crankcase heater voltage B may vary but is secondary. Model number matching C isn't mandatory if performance matches. Discharge line sizing D matters but usually remains consistent. Oil compatibility is critical for longevity. Question 23. In summary of a recent incident where a technician suffered frostbite from improper refrigerant handling, Mr. Martinez wants to reinforce safety culture. Which measure best fosters proactive safety leadership? A. Strictly enforcing PPE policies with immediate penalties for violations. B. Leading by example and conducting regular, interactive safety trainings. C. Outsourcing safety training to certified external consultants. D. Providing safety manuals but allowing technicians to self-regulate PPE. Answer. Correct answer. B. Explanation. Leadership by example and interactive training build a strong safety culture more effectively than punitive or passive approaches. OSHA recommended practices. Outsourcing C may help but does not replace internal leadership. Simply distributing manuals. D. Risks non-compliance. Positive reinforcement, engagement, and leading from the front ensure consistent safety adherence. Question 24. Given the circumstances, an HVAC system installed in a hospital wing uses HEPA filtration, but staff complain about odors and airborne contaminants. What is the most plausible cause? A. HEPA filters do not remove volatile organic compounds, VOCs, or odors effectively. B. The filters are installed backwards, reducing filtration efficiency. C. The system UV dermicidal lamps are malfunctioning. D. The air change rate per hour is too high, causing pressure imbalances. Answer. Correct answer. A. Explanation. HEPA filters capture particulates but do not absorb gases or odors. E.g. VOCs. Activated carbon filters or specialized filtration media are needed for odors. Incorrect filter installation. B. Reduces particulate capture but not specifically odors. UV lamps. C. Target microbes, not odors. Excessive air changes. D. Cause pressure but not odor issues. Understanding filtration limitations is key for indoor air quality management. ASHRAE 170. Question 25. Across different scenarios, a training manager explains the importance of correct duct velocity in residential HVAC systems. What is the primary risk of excessively high duct velocity? A. Increased noise and air turbulence causing occupant discomfort. B. Reduced airflow leading to uneven heating or cooling. C. Increased static pressure improving filtration efficiency. D. Reduced duct leakage improving system efficiency. Answer. Correct answer. A. Explanation. High duct velocity causes turbulent airflow and noise, leading to occupant discomfort and system inefficiency. A CAM manual. D. Reduced airflow. B. Usually results from undersized ducts, not velocity. Increased static pressure. C. Strains fans and reduces efficiency. Reduced leakage. D. Is desirable but unrelated to velocity. Proper duct design balances velocity, noise, and pressure loss. Question 26. When analyzing control circuit failures, a technician finds a relay coil energized but the contacts do not close. Which is the most probable cause? A. Coil voltage is higher than the rated voltage. B. Mechanical failure or welding of relay contacts. C. Incorrect relay coil polarity. D. Thermostat anticipator set too high. Answer. Correct answer. B. Explanation. If the coil energizes but contacts do not operate, mechanical failure, sticking or welded contacts is likely per NetCam manufacturer. Troubleshooting guides. Coil voltage too high. A. May burn the coil but usually prevents energization. Polarity. C. Generally does not affect relay coil operation in AC circuits. Thermostat anticipator. D. Affects control but not relay mechanical action. Question 27. The fundamental question is why a technician measures subcooling at 5 degf on system designed for 12 degf. What should be the immediate interpretation? A. System is undercharged or has condenser airflow issues. B. Refrigerant is overcharged causing liquid floodback. C. Expansion valve is stuck open causing flooding. D. Compressor valves are leaking causing pressure imbalance. Answer. Correct answer. A. Explanation. Low subcooling, 8 often signals undercharge or poor condenser heat rejection per HVACR guidelines. Overcharge, B, usually leads to high subcooling. Stuck expansion valve, C, would cause low superheat, not subcooling. Leaking compressor valves, D, affect compression but don't directly lower subcooling. Proper refrigerant charge and airflow ensure subcooling within specification. Question 20. For many years, Mr. Lee has struggled with explaining complex HVACR concepts to non-technical management. Which communication approach would best improve understanding? A. Use technical jargon to demonstrate expertise. B. Present data visually with graphs and simplified analogies. C. Provide lengthy written reports to cover all details. D. Avoid technical details and focus only on costs. Answer. Correct answer. B. Explanation. Visual aids and analogies simplify complex ideas, enhancing comprehension and decision-making. Communication best practices. E. In corporate training standards. Jargon. A. Alienates non-experts. Lengthy reports. C. Risk overload. Ignoring technical content. D. Reduces credibility. Clear, concise communication tailored to the audience is key for training managers. Question 29. Despite the fact that a heat pump system passes electrical tests, the compressor repeatedly trips on overload during high ambient temperatures. What is the most likely cause? A. Incorrect refrigerant charge causing high head pressure. B. Faulty contactor causing intermittent compressor start. C. Defective capacitor reducing motor start torque. D. Dirty evaporator coil restricting airflow. Answer. Correct answer. C. Explanation. A defective startron capacitor reduces torque, causing motor overload and tripping, especially under load. Neck and manufacturer guidelines. Overcharge, A, affects pressure but usually trips high-pressure switches, not overload. Contactor issues, B, cause start failures but not overload trips. Dirty coils, D, affect cooling but don't cause overload protection trips directly. Question 30. From multiple perspectives, what is the best method to objectively assess HVACR trainees' competency beyond written exams? A. Oral questioning during class sessions. B. Hands-on practical tests simulating real-world scenarios. C. Group projects evaluating teamwork skills. D. Open book quizzes to test research skills. Answer. Correct answer. B. Explanation. Hands-on practical assessments are essential to verify skills, application, and problem-solving under real conditions. Astomy. Or questioning. A. Assesses knowledge but not skills. Group projects. C. Evaluate collaboration but less on individual technical skill. Open book quizzes. D. Test research but not applied competency. Practical testing aligns with industry certification standards.